Hello, Iram. Am I audible to you?
Hello,
Hello.
sir. Yeah, you're audible.
Okay, could you let me know what did I teach you in the last class? I think Coulomb's law.
Yes.
And what about
This,
what about equilibrium? Equilibrium. Did you teach you in the last? Did I teach you in the last class?
we've just started with it.
Okay, fine. Let's start with this topic again. So, what do you mean by equilibrium? Equilibrium means let it be two charges. Just a minute. Okay, let it be two charges, Q1 and Q2, and let it be three charges, Q3. If the three charges in equilibrium means if the three charges or the entire system is equilibrium means if we have to calculate the force in any of the charge, then it will come out to be zero. So if the net force in any of the charge is zero, then we say the entire system is in equilibrium. Fine. Now start with this question. The question is saying the two charges E and 4E are placed at a separation A, at which point on the line joining the charges we place so that they are in equilibrium. So plus E and plus 4E. These are two charges separated by a distance A. Now, at which point, let it be Q from a distance E, it would be A minus X. So let it be Q is the place where the charge Q is in equilibrium. Now, if we have to calculate, the question is saying the given charge is in equilibrium, it means the net force on Q is zero. So net force, it means the force due to Q, due to E, and due to 4E. Let it be F1 is the force due to plus E. So it would be 1 over 4 epsilon QE over X square. And F2 equals to 1 over 4 epsilon Q into 4E over A minus X square. Now, so the net force, it's 0. It means F1 vector plus F2 vector equals to 0. It means F1 vector equals to minus F2. And if we take magnitude both sides, means the magnitudes are equal in, the forces are equal in magnitude, but opposite in direction. So F1 is 1 over 4 epsilon Q E over X square and 1 over 4 epsilon 4 QE over A minus whole square. QE will cancel out. This will cancel out. So X square equals to 4X square equals to A minus X whole square. We have to take a square root both the sides. So plus minus 2x equals to A minus x. We can take out 2x equals to A minus x. So 3x equals to A. So x will come out to A by 3. This is the first possibility. Or minus 2x to, if I take it this side, then x equals to minus A, which is impossible. This is not the possibility. So did you get it, this first one? If we have to calculate the distance Then what we have to do it indirectly? We have to equate these two forces. First of all, we will calculate the force due to E on this chart, and then for it on this chart, then equate the magnitudes, you'll get the answer. But you are not supposed to, while calculation, you're not supposed to use A minus B whole square, because if you do, then it's going to be very complicated. Fine. So this is how we do. Is it okay, Iram? Shall I proceed?
Yes, sir.
Now, the second part of this question is calculate the nature and the position. So the arrangement was plus E plus 4E this is Q at a distance A over 3 from E, and this is remaining will be 2A over 3 because the total distance is A. Now, we have to calculate the nature and the position. Position we calculated, that is A over 3 from plus E. Now, we will calculate the magnitude of the charge. So how to do? Look, whenever we have to calculate the magnitude of the charge, the system is in equilibrium. Fine, the system is in equilibrium. It means if we have to calculate the force in any of the charge, it's going to be 0. Fine. Means whenever we have to calculate the magnitude of charge, it means you have to target either this charge or this charge. It's completely up to you. So this time I'm taking this charge. This is the trick. Remember this thing. So 1 over, it means the net force on plus E is also 0 because the entire system is in equilibrium. So calculate the force due to this on E, that is 1 over 4 epsilon QE over A over 3 whole square. Likewise, now we have to calculate force on E due to this also, because the charge on, because the net force on plus E is also 0. So 1 over 4 epsilon 4E square over the distance is A between these two charges. So 1 by 4 epsilon, 1 by 4 epsilon will cancel out. E will cancel out. So Q over 9Q over A square equals to 4E over A square. A square will cancel out. So square E. Answer will be 4E over 9. Is it okay, Iram? How to calculate the magnitude of charge?
Yeah.
Now further we have to find out the nature. How to calculate the nature? Look, for now, just let it be Q is positively charged. Okay, for now. Look, if Q is positively charged, so plus E plus Q and plus 4E. For instance, let it be 4 plus Q is a positively charged. Now, the question is saying the entire system is equilibrium. Means if I calculate the force in any of the charge due to the rest of the two charges, then the force will come out to be 0. So target this chart. Now, if I have to calculate the net force on this chart, okay, Iram, just let me know one thing. If what is the direction of the force due to plus Q on E? What is the direction? Towards right or left?
Towards left.
Towards left. Look, let me tell you one more thing. Like charges, basically, like charges push, okay? And unlike charges pull. This, remember the thing. These two charges are like charges. It means the force on plus E due to plus Q is towards left. Okay, let it be F1. Now, plus 4E. Okay, now let me know. Just forget about this charge. Now, let me know the direction due to 4E on plus E. What is the direction?
Towards right.
Towards right. Due to this also. Look, this is plus E and this is 4E. Charge. Both are positively charged. Both are like charges. And if I have to calculate the direction of plus E, so what is the direction? This charge will try to push this. Then it would be towards left again.
Oh, yeah.
Fine. So F1 and F2 both have same direction. Okay. F1 and F2 both have same direction. So just let me know. Can we say the force on plus E is 0? Because the directions are same. Can we say?
Yeah.
Look. If F1 and F2 both have same direction, Iram. All right. So it is impossible that the force on E is 0. It's impossible. Because if the net force on plus E is 0, it means force must be in opposite direction. All right. Because then only the force will be cancel out each other. Otherwise, how it is.
Oh, okay. Yeah,
Okay.
yeah.
Both the forces have same direction, so it is impossible. Fine. So Q will be negative. Okay.
Yes.
Q will be negative. Q. So the nature of the charge is negative. Q is negatively charged. So the magnitude is minus 4e over 9. This is the answer. Okay, I'm done.
Yeah, done.
Okay, just a minute. Now, types of equilibrium. There are three types of equilibrium. First is stable equilibrium, unstable equilibrium, and neutral equilibrium. In stable equilibrium, the force is zero because it is in equilibrium means the net force is zero. But what is the difference between these three equilibrium? Now, first one, in stable equilibrium, the force is zero because it is in equilibrium. Body will regain its position. Means let it be this body. If I move up to this, let it be this is a bowl, and if I move this body till here, then definitely this body will regain its position. That means it will try, means it will come back to its original position, like on at this place. Fine. But in case of unstable equilibrium, if I displace this body is not able to regain its position. That is unstable equilibrium. Fine. In case of stable equilibrium, the potential energy is minimum. Fine. Potential energy is minimum. And in case of unstable equilibrium, the potential energy is maximum. Because if you compare with this, the height is let it be this is a reference point, so height is 0, and at this the height is much greater than this. So this is unstable. In case of unstable equilibrium, potential energy is maximum. In case of stable equilibrium, potential energy is minimum. But in case of neutral equilibrium, the body will be at means at the same position at equal points like this. After some time, this will here means all the points are at the same level. Fine, and the potential energy is constant. In case of stable equilibrium, the body will regain its position and the potential energy is minimum. In case of unstable equilibrium, the body is not able to regain and potential energy is maximum. In case of neutral equilibrium, the force is 0, but body will be at the same level at every point and potential energy is constant.
Okay.
Now try this question. It's not too difficult, but try this. This question is very easy. The point charges plus 2q minus q 4q are kept on the axis. Look, let me draw the figure for you first. Just a minute. The question is saying there are three charges. This is x equals to 0. This is x equals to minus a. And this is x equals to 2. Leave this question. for now. Try this question, Iram. This question is easy. This question is similar to the last one that I told you. Try. You have 4 minutes to do this question, and if you get any doubt, please let me know. Okay? There is no need to help you. Fast. Iram, are you getting this question or you getting problem?
How I am doing?
You are doing great. Do.
Is it minus q by 4?
So let's discuss. A Q is placed at the center of the line joining the two positive charges separated by a distance, let it be A. The system 3 charges will in equilibrium. If Q is equals to, okay. The charge is placed midway. Let it be Q. And this is A over 2. Is also A over 2. So again, KQQ over A over 2 whole square. Magnitude we have to calculate, sorry. Okay, fine. So we have to target in any of the chart. Let it be this. Equals to KQ square over A square. QQ will cancel out. KK will cancel out. So QA over 4A square equals to, sorry, this is 4Q. This is Q over A square. This is Q equals to Q over 4. And what is the nature? Did you understand how to find out the nature of the given charge? Because look, it's a trick. If the two charges are having same nature, then the third would be opposite nature. So Q equals to minus Q over. Okay, Iram? Is it fine?
Yes, sir.
Great. Now, this concept is clear, equilibrium.
Yeah, clear.
And stable and unstable is also clear.
Yes,
Okay, try this question. Which subject means you have mathematics or biology?
both.
Both. Okay. Now try this question. And you have to stay for your class assessment. Okay.
Sorry, sir.
You have to stay for class assessment. Class assessment
Like, what's the time?
after the class.
So,
Okay.
so,
Yes.
actually, after the class, we have iftari here, so I don't think
I
it's
don't.
possible.
I don't know. You have to discuss with the team.
Okay.
Okay. Let me confirm. Iram,
Yes, sir.
I think you have assignments also, isn't it?
Yeah.
Okay, fine. From electric field, we have done electric charge and Coulomb's law.
Hmm.
Fine. You have to do uh, question number first,
Okay.
question number second, third
Hmm.
at home in homework.
Okay.
And question number 1, 2, 3, 4, 5, 6. That's it.
Where should I submit the assignments?
Sorry,
Where should I submit the assignment?
I'll let you know. And from Coulomb's law assignment, question number 1, question number 2, question number 6, question number 7, question number 8, question number 9. That's it. Okay, written?
Yes.
Okay, fine. Now try this question. Very easy. Look, you have to use the concept. You have to use the concept. If the charge is not able to regain its position, then it is unstable. And I think you'll do it. You are good in academics.
So charges are stable, unstable. Sorry, option
And
C.
correct. Because there are three charges. Three charges plus 2q. And this is minus q, I think. Minus q, again plus 4q. And they are placed at, this is at origin, this is at A, and this is at 2A. It means the distance between them is 2A, and this is at the center. So if I displace minus q towards right, so the force will be attractive. So this will try to, the force due to plus 2q is F1, and force due to plus 4q is F2. So if I displace minus q towards a little bit towards q, so definitely force is inversely proportional to the distance. Fine. So distance will be decreased, hence the F2 will be increased. F2 is greater than F1, hence the minus q is not able to regain its position. Unstable equilibrium. Okay.
Okay.
Now next. Principle of superposition. Now, principle of superposition means, so let it be a charge, and we have to calculate the force on Q naught. Let it be, this is a Q naught. And if I have to calculate the force due to Q1, due to Q2, due to dot, due to Qn. So what we will do? We will do the vector sum. So first of all, we will calculate the force due to Q1, then Q2, then Qn. And we will sum up according to the vector's law of addition. Do you know vector's law of addition? Iram, do you know
Yeah,
vector?
a bit.
Okay, I'll revise them. Don't worry. So what does it state? What does it state? So if the n number of charges, if a charge is surrounded by n number of charges, and if we have to calculate the net force due to the rest of the charges, fine, then what we will do, we will calculate the force due to Q1, then due to Q2, due to Q dot, due to Qn. Fine, and we will sum up according to the vector sum of addition. Just a minute, Iram. Sorry. Look. So let it be n number of charges, and if we have to calculate the force in any of the charge due to the rest of the charges, what we will do? We will do the addition due to single charge, then due to second, then due to third, due to n number of charges, and we will do addition according to the vector's law of addition. Fine. So just let it be, these are the charges Q1, Q2, Qn. Now, if we have to calculate the force due to Q1, so the force will be repulsive. If it is positive charge, the force will be repulsive. As I told you, if the charges are like charges, then they will try to push each other. And due to Q2, they will try to push each other in the upward direction like this also. And we will do vector's law of addition. That's it. And just remember one thing, the force between two charges is not affected by the presence of other charges. Means if we calculate the force due to Q1, means the force between Q1 and Q0 is not affected by the presence of Q2, Q3, Qn and other charges. Now this is the question. Try this question. The charges are plus 5 microcoulomb, 10 microcoulomb, and minus 10 microcoulomb are placed in air at the corners of A, B, C of equilateral triangle having side 5 centimeter. Calculate the resultant force. Calculate the resultant force on the charge at A. Fine. Just read this question. I'll do for you. Done, Iram?
So I'm noting the question. Just a minute.
Look, there are three charges, 5 microcoulomb. This is the question. There are three charges, 5 microcoulomb, 10 microcoulomb, minus 10 microcoulomb are placed in air at the corners of A, B, C of equilateral triangle, having side 5 centimeter. Calculate the resultant force on the charge at E. Once you read, just let me know. Once you read the question, please let me know. Done, Iram?
Yes.
Okay, before that, first of all, go through the vectors. So vectors. What is a vector quantity? Having vector, having magnitude and direction plus vector's law of addition. That is triangle law and parallelogram law. A is denoted by A vector. Let it be A is a vector. So it is denoted by A vector. This is the way to represent. This is known as head and this is known as tail. Force F equals to 2 Newton due east. It means the force is acting towards the east direction and its magnitude is 2 Newton. 2 Newton. Fine. This is the magnitude notation. For example, the force is given 2 Newton. If I have to write the magnitude, either we will write this way or F equals to 2 Newton. This is the way to represent, to write the magnitude. Next, a unit vector. A unit vector, a vector having magnitude 1 and gives the direction of the given vector. So let it be A is any vector. Fine. It is denoted by A cap. The magnitude is 1. This is the formula. A cap equals to A vector over A magnitude. Now unit vectors I, J, K are unit vectors and they are orthogonal vectors. Orthogonal means all three vectors are perpendicular to each other. In Cartesian form, A vector equals to AX I cap, A2 J cap, A3 K cap. If I have to calculate the magnitude, this is the formula A1 square, A2 square dot dot. Sorry, A1 square, A2 square plus A3 square under root. Look, calculate the magnitude. Just do this question for me. 2I cap plus 4J cap. Calculate the magnitude, Hiram. And once you have done, please. What is the answer? Hiram done?
Just a minute.
Okay.
Under root 20.
Under root 20. So a equals to 2 square plus 4 square, that is 16 plus 4, that is 20. Okay, 20 unit. Now, what is a cap? Fast. What is a cap?
Uh, 2i plus 4j, 2i cap
2i cap plus
plus
4j cap
4j
over
cap over under root.
20. Okay, this 20. Good. Do you have mathematics?
Yeah.
Okay. Now try this. You can try this question. The charges of 5 microcoulomb, 10 microcoulomb minus 10 microcoulomb are placed in air. Now try this question. What is given in the question? The three charges. One is 10, 5, 5 and minus 10. Okay. 5 plus 10 and plus 10 microcoulomb. Okay.
Okay.
Now it is an equilateral triangle having side. What is side is given?
60.
570. Sorry, 5 centimeter. And there are three charges. This is A, this is B, this is C. Okay. Now we have to calculate the net force on A. Okay. Look, just let me know one more thing. What is the direction of the force due to plus 10 microcoulomb on 5 microcoulomb? Please let me know along BA or AB. This way or this way? Hiram,
So can you repeat?
look, if I have to calculate the direction of the field of the force due to plus 10 microcoulomb on plus 5 microcoulomb, it is along BA or AB. Just remember, like charges push each other.
BA.
BA, good. Now, so due to this, it would be like this. Okay, let it be F1. And due to minus 10 microcoulomb, it is along AC, that is F2. So resultant force will be like this. Okay. Are you familiar with triangle of addition and vector and parallelogram law of addition.
Yeah.
Okay.
Parallelogram.
So F1 is a vector, F2 here. So what is F1? F1 is 1 over 4 epsilon 10 microcoulomb means 10 to the power minus 6 into 5 into 10 to the power minus 6 over what is distance 5 centimeter. 5 centimeter means 5 into 10 to the power minus 2 whole square. And write the directions as well along BA. This time. Fine. And F2 equals to 1 over 4 epsilon. Sorry. First of all, we will calculate it. Now, solve. This is 9 into 10 to the power 9. It would be 50 into 10 to the power minus 12 over 25 into 10 to the power minus 4. So this will cancel out to 18 into 10 to the power 9 10 to the power minus 3 minus 3 10 to the power 4. That is equals to 180 newtons. Is it clear? Along BA. Till here, is it clear to you?
Yes.
Now, just remember the force means F2 will be equal in magnitude because the charges are same, the distance is same. Okay. Now, so F1 is like this and F2 is like this, and the angle between them is 120 because this is 60, this is 60, this is 60. That is a linear pair. This it would be 120. Now, what is the formula to calculate the resultant force? Let it be F is the resultant force. So 180 square plus 180 square plus 2 into 180 into 180 into cos 120. Calculate for me. Fast, Iram. Let me know the answer.
Sir, how is it cos 120?
Look, it is a equilateral triangle.
Hmm.
60, 60, 60. If I, it, it would be that one entire, it is a linear pair, 60 and this angle on a line is 1,
Yeah, okay, okay, yeah.
would be 120. Done, Iram? Okay, why you're not able to attend
And
class? Done?
yeah,
How much? 180. What is the answer, Iram?
so I got under root 3240.
Just a minute. 80 square. You are not supposed to open. It would be 2 into 180 square into minus 1 by 2. Because what 20 is minus 1 over 2. Now 2 will cancel out. It would be 180 square plus 180 square minus 180 square. These two will cancel out. 180 square will remain. So 120 is the Newton. Towards left. Towards right, sorry. Okay.
Okay.
Try this question. This is minus q here. This is plus q. This is again minus q. This is plus q. This is a square. Now calculate the net force on this charge. This is A, this is B, this is C, this is D. Now calculate the force on this charge. Fast, Iram. Try this question. Okay, why are you not able to attend class assignment, class assessment session?
The after class test, that one?
After class?
Right now you said about that after class test.
No, it's not a test.
Then,
It's an assignment session, that's it.
oh, it's iftari here, so
Sorry?
it's iftar time here. After the class, after the class, it's iftari time here.
I'm not getting what I'm saying, seriously. After the class?
So wait. So it's iftari time here after the class. I won't be able to appear.
Okay, you won't be able to appear. Okay. I told them, by the way. They will
Okay.
contact you. Okay.
Okay.
Okay, Ramzan are going on, isn't it?
Yes.
Okay. Sorry, I don't know. Okay. Hello, Iram.
Yes, sir.
Did you understand the concept of triple superposition?
Yeah.
Okay, boy. Fine. Do you have any problem?
Not yet.
Okay, just a minute. Okay. And do all the questions. Okay, I marked some of the questions from the assignment. You have to do it.